Ever wonder how your phone's smart assistant knows the answer to your questions, without just guessing? Or how AI can write code, analyze research, or even help doctors diagnose diseases? It all starts with something called retrieval systems, the secret engine behind modern AI. Let's break it down. Imagine you're searching for a recipe online. A basic search engine might just look for the words cake and ingredients. That's sparse retrieval, like keyword matching. But modern AI is way smarter. It uses dense retrieval, where it understands context, not just words. Think of it as reading between the lines, instead of just scanning for keywords. Now here's where it gets cool. Techniques like BM25, a classic algorithm, or Contriever, a neural model, help AI rank results. Some systems even use CLIP, which connects text and images, or BERT, a language model that grasps meaning. And there's called BERT V2, which breaks text into tiny pieces to spot subtle patterns. It's like giving AI a magnifying glass for hidden clues. But wait, there's more. For complex tasks, like coding or multi-step reasoning, researchers use hybrid approaches. For example, hierarchical two-step retrieval first narrows down options, then fine-tunes with AI prompts. Or iterative retrieval, where the system keeps refining its search based on feedback. It's like having a conversation with the data. And let's not forget the tools. GPT, Llama, Claude, these models don't just retrieve info, they generate answers. Meanwhile, knowledge graphs and entity linking, like TAGME, help AI connect dots between concepts. In software engineering, these methods solve real problems. Imagine an AI that finds code snippets, debugs errors, or even writes code based on your description. Tools like CodeSearchNet and Repo-Eval train systems to understand programming languages, while semantic code diff retriever spots changes in code logic. But here's the game changer, Retrieval-Augmented Generation, RAG. It's like giving AI a superpower. It can look things up while still sounding human. For example, if you ask, what's the latest on climate change? RAG systems automatically fetch the most recent studies, blending real-time data with AI's ability to explain it. Tools like Flare or Rind plus QFS let the AI rewrite your question into 10 versions, then pick the best answers, like a detective cross-referencing multiple leads. And it's not just about speed. RAG is expanding beyond text. Imagine a chatbot that doesn't just read a tweet about a disaster, but overlays it on live satellite images. Or a doctor's assistant that pulls up both a radiology report and the actual X-ray image. Systems like Murag use unified models to mix text, images, and tables in the same, embedding space, like a universal language for all data types. So what's a benchmark exactly? Imagine training a dog to fetch a ball. You'd start with simple throws, then add distractions, then make it run faster. Benchmarks work the same way for AI. They're carefully designed tests that measure how well models handle real-world challenges. For example, while an AI might ace a math problem in a textbook, benchmarks like GSM-8K force it to solve multi-step problems with real-world twists. No cheat sheets allowed. But benchmarks aren't just about testing. They're also about teaching. Take AC, a dataset that turns AI into a debate partner. It asks models to ask follow-up questions, like a human would, forcing them to think critically instead of just spitting out answers. Or look at PTBXL, a library of heartbeats that trains AI to spot irregularities in medical data. These aren't just numbers, they're life-saving clues. Here's the kicker, benchmarks reveal AI's blind spots. A model might generate convincing medical advice, but without the right tests, it could miss critical nuances. That's where datasets like PubMed QA or BioASQ step in, challenging AI to tackle complex biomedical questions. It's like giving a robot a medical exam, only the questions get harder over time. And it's not just about smarts. Benchmarks push AI to be fair, safe, and reliable. EdBench and ANLI act as digital stress tests, tricking models with misleading prompts to see if they stay on track. Meanwhile, Truthful QA ensures AI doesn't just repeat facts, it learns to spot lies. So why does this matter to you? Every time you chat with a chatbot, get a medical diagnosis, or watch a self-driving car, benchmarks are quietly working behind the scenes. They're the reason AI isn't just memorizing answers, but understanding context, adapting to ambiguity, and growing smarter. Next time you hear about an AI breakthrough, remember, it's probably built on the back of one of these benchmarks. They're the unsung heroes of. Oh wait, there's more. Ever wonder how AI really understands us? It's